DC load line. The basic principle of application of a transistor is an amplifier. Here it includes a high resistance or impedance in the output circuit, whereas a low resistance in the input. So let's consider a CE configuration. So CE configuration means a base resistor is connected to the base, load resistance is connected to the collector, and the biasing voltage is given by VCC. The zero signal conditions is called quiescent condition. This battery VCC sends a current through the load resistance RL. Let IE, IC and IB be the emitter current, collector current and the base current. Then applying Kirchhoff's condition, here this voltage, this VCC is the voltage we are applying from the external source. This voltage is dropped across the load resistance as IC into RL, and there is a potential drop across the collector emitter, and that is a collector emitter voltage. So VCC is equal to ICRL plus VCE. So from this we can find IC is equal to VCC minus VCE divided by RL, or minus 1 by RL VCE plus VCC by RL. This equation is an equation of a straight line, mx plus c, here where m is the slope. Taking IC along the y-axis and VCE along x-axis, there we will get a straight line with a slope m is equal to minus 1 by RL, and y-intercept c is equal to VCC by RL. The straight line is called DC line. To draw DC load line, we require 2 points A and B. A is this and B is this. Drawing a graph with the VCE along x-axis and IC along y-axis. Then let's consider the point A. At the point A, y is equal to IC equal to 0. Here IC equal to 0 and VCE is equal to VCC. So the point A is VCC 0. At point B, VCE equal to 0. Here VCE equal to 0. Hence from the equation we get IC equal to VCC by RL. So this point B is 0 VCC by RL. The slope of the load line is given by m is equal to tan theta is equal to minus 1 by RL. This is the load line. Load line is a straight line graph with the slope m is equal to minus 1 by RL. Then what about quiescent point? The values for the analysis of the performance of a common emitter amplifier, we need to find the values of ICE and VCE under quiescent condition. Quiescent condition means zero signal condition for a given values of IB, RL and VCC. These values can be determined by the load line analysis. The operating point. The zero signal values of IC and VCE are known as operating point or working point. These values of IC and VCE fix up the operating point of the transistor. The operating point is decided not only by the characteristics of the transistor but also by the number of other factors including VCC, RC, RB, VBE and VBB. VBB, that is the base voltage, is equal to IB into RB plus VBE. That is, this is the supply voltage VBB. This is the external voltage we are supplying. This voltage is dropped across this resistance and across this base emitter junction. So these two voltages, dropped voltages are IB RB plus VBE. So VBB is equal to IB RB plus VBE. From that, IB is equal to VBB minus VBE divided by RB. The point of intersection of the DC load line with the output characteristics for a known value of base current is called the operating point. For Q point for the amplifier, the operating point, the required base current IB, the DC collector current IC and the DC collector emitter voltage. For faithful amplification, the Q point must be exactly at the midpoint of the load line. Then what about AC load line? the load is not a single resistor like RL. So in such a case, AC load is bound by the equivalent impedance. We have to consider the equivalent impedance of all the circuit components in the collector to emitter circuit. If RAC is the equivalent impedance between the collector to emitter, the load line with the load RAC instead of RL is called AC load line. The slope is M is equal to minus 1 by RAC. Instead of RL, here the effective impedance is RAC. This is the AC load line. The Q point is a point of intersection of AC and DC load lines.